All right, now to space. With NASA planning to head back to the moon in 2024, have you ever wondered if there is a connection between the Earth's volcanoes and the moon or possible life on other planets? That's what scientists are trying to find out. I talked to one of those scientists to get some answers. Have you ever looked up at the moon and wondered, how did it get that way? Did it ever have water or life? Does it have anything in common with Earth? For over a decade, scientists at NASA's Goddard Space Flight Center have studied materials retrieved from the moon by different spacecraft to answer those questions.
And so we've been studying the data from this spacecraft, obviously, for the last decade. And we've noticed a few really interesting things about some of the data that's coming back.
What they've discovered is the moon shares something very similar to what can be found here on Earth.
So from previous mission, we saw that there was this weird kind of radioactive anomaly on the far side of the moon. On the near side, we tend to see that associated with volcanic materials. But on the far side, which is where we've been looking, there wasn't kind of a great explanation for what this material was. So we used new data to integrate a lot of different compositional trends. And we showed that this material is kind of the leftover sludge from an early global melting event.
Anytime I think of molten events or magma or anything of that nature, I'm thinking, of course, volcanoes here on Earth and how it helps to create even more land and all of that. And the same similar effect may have occurred on the moon as well.
Yeah, so things are slightly different on the moon. So what we're talking about in this paper is an early global melting event that melted the entire moon to depths of hundreds of kilometers or more. And so actually, this isn't something that's unique to the moon. We actually think that most large rocky planets do undergo this kind of global melting event early in their history. So by studying this process on the moon, it helps us to understand how kind of all rocky planets work, including the Earth.
And what do you hope to learn from all of this? Because I know you said it's 10 years worth of information that you were studying, but what do you hope to learn?
So a big thing that we're looking to learn is how planets handle kind of heating and melting over time. So most rocky planets start off very hot early in history. And so we're kind of interested in what happens to that heat over time, and then what are some of the other possible sources of heat that may show up. We kind of turn that around to think, okay, what are the implications for life on Earth? Well, if we're thinking about future asteroid impacts, maybe the worst thing to worry about isn't the actual impact, it's the possibility of millions of years of fallout of volcanic activity. So these have kind of wide-ranging implications and effects for life kind of everywhere. Understanding how planets form in general is really important. So the formation and the evolution of planets. On Earth, something really different happens, which is the Earth undergoes plate tectonics. And plate tectonics is really important for building kind of the continental crust, the land we live on. So understanding what happened in the process to separate a planet without plate tectonics, like the moon or Mars, into planets like Earth, which have plate tectonics and are a little bit more favorable to life. Understanding the distinction will really help us understand kind of where we came from and identify other planets that might sustain life, either in our solar system or beyond, around other stars.
That's so interesting, and the research is not over yet. To learn more, head to our website, CW39.com, after our show. Let's go and take a live look, courtesy of that Sky Tracker Network, outside, this time towards Galveston and the Babes Beach Cam, looking at the renourishment project still underway. Looking great. We're CW39 Houston. No wait weather and traffic.